Hello, everyone. In this video, I will introduce our latest work, Open Vocabulary HOI Detection with Interaction-Aware Prompt and Concept Calibration. Humans interact with objects around them continuously in daily life. Thus, recognizing and detecting these interactions is crucial for agents to grasp the environmental context and engage efficiently with people. Given an image, our goal is to detect a set of human-object interactions. This involves identifying the bounding boxes for both the human and the object instances, as well as classifying the object and interaction categories. Despite recent progress, previous clip-based approaches still suffer from the region and image-level perception misalignment. Specifically, HOI detection requires fine-grained reasoning on localized image regions, whereas clip is trained on holistic image understanding. This discrepancy introduces a distribution gap, impeding the model's detection performance in complex scenes. Besides, they suffer from suboptimal text-visual alignment for fine-grained HOI concepts. Specifically, current methods struggle to capture the subtle intra- and intermodal relationships necessary for differentiating visually similar actions. This issue stems from the region-level misalignment mentioned above. Clip's image-level pre-training fails to establish fine-grained visual-text correspondences, leading to the loss of critical action distinctions. For instance, words like hurl, throw, and pitch have distinct meanings but are often weakly aligned with visual cues. Similar backgrounds or irrelevant regions further disrupt learning, making it hard to distinguish actions like hurling versus pitching, as shown in the right figure below, limiting adaptability to novel interactions. We propose a novel end-to-end encoder-decoder architecture for open vocabulary HOI detection. Our INP-CC framework addresses these challenges using an interaction-aware prompt generator and concept calibration mechanism, illustrated in the upper and lower blocks in the figure below, respectively. To bridge the gap between image-level pre-training and fine-grained region interaction detection, we first propose an interaction-aware prompt generator that adaptively incorporates common prompts and interaction-specific prompts via a selection mechanism. This generator guides the visual encoder to better focus on the critical interaction regions. To address the limitations of current vision language models in handling diverse and fine-grained interaction concepts, our INP-CC introduces an interaction concept calibration mechanism. This mechanism leverages large language models to generate and calibrate visual descriptions, allowing the system to capture much richer semantic details. First, in the inter-modal relation modeling stage, INP-CC generates fine-grained visual descriptions for each interaction type, and then uses the TY language model to turn these descriptions into embeddings. This helps the model tell apart actions that look similar but actually mean different things, for example, picking up versus holding. Next, we design a negative category sampling strategy. Since some actions are visually alike but conceptually distinct, INP-CC samples negative examples based on semantic similarity. During training, it deliberately contrasts categories that are visually close, which teaches the model to better recognize subtle differences in action semantics. We evaluate our method on the widely recognized HOI detection benchmarks, including SWIG-HOI and HICO-DET. The SWIG-HOI dataset encompasses 400 human actions and 1,000 object categories. The test set of SWIG-HOI comprises approximately 14,000 images and 5,500 interactions, with around 1,800 interactions not present in the training set. The HICO-DET dataset provides 600 combinations involving 117 human actions and 80 objects. The table below presents the quantitative results. On both the SWIG-HOI and HICO-DET datasets, our method achieves state-of-the-art on all splits. Ablation study shows that each module, including interaction prompts abbreviated as IP, and concept calibration abbreviated as CC, shows performance gains. Combining the proposed modules achieves the best results. We also visualize the prediction result and attention maps to illustrate the characteristics of our method. We observe that our model demonstrates a strong ability to focus attention on key interaction regions. In conclusion, we introduce an interaction adaptive prompt generator, a novel mechanism for prompt generation and selection that enhances the model's adaptability to various scenes by incorporating interaction-specific knowledge. We leverage large language models to capture HOI concept relationships, using this information to sample negative categories for enhancing intermodal modeling. Experiments on SWIG-HOI and HICO-DET datasets demonstrate that our proposed method achieves state-of-the-art performance in open vocabulary HOI detection. Thanks for your attention. Scan the QR code for more details.